Hi everyone, so my name's Ofer. A little bit about me, I run developer relations for Vectara. I've been with the company for about 2 years. And by background, I'm a machine learning engineer. I used to work in different companies in Silicon Valley, and I got to work on LLMs quite early on. I like to say I used GPT-2 when it just came out. So lots of interesting stories about that, about how much they thought that is going to be dangerous for the world. GPT-2 is, but we are at GPT-4, and it's still not quite there, but it's getting close. As Sasha said, at Vectara, we deal with RAG and agents, which is we're going to talk about more about the agent stuff, but just to kind of set the stage. For RAG, I'm sure you've seen other diagrams like this, but RAG is this idea that you take, instead of calling the LM directly and having it respond based on your particular, its particular training set, you point it to a data set that's usually a private data set for a company or something like this, and you get the LLM to be grounded in your data. So the flow is, instead of going kind of vertical here, you sort of have first a retrieval part, and you get the facts out of the data set, which could be millions of documents from anywhere, and you send them to the LLM, the ones that are the most highly matched, and you ask the LLM to essentially respond grounded in this data, as opposed to grounded in its just training set, which is usually the web. This is what it looks like in a little more detail. So when you build a RAG stack, you essentially have the first step is the ingest step, where you take data from maybe a Google Drive or a database, or it could be Jira, or we have connectors, a lot of different types of sources. And you essentially you can add metadata to it, and you send it to extraction. If it's a PDF file, you want to extract the text from that. You do something called chunking. And then a lot of other processing for multimodal, like table and images. And then you store it in something we all know as a vector database. And then during query time, you can run a query. You again can define a lot of parameters of how to filter, etc. Again, the query is embedded to a vector space. You do this matching on the vector database side. And then usually people kind of are more knowledgeable about the vector search, but actually in RAG, there's usually more steps involved. You want to do something called hybrid search, which combines lexical kind of keyword-based search with vector search. You want to consider doing re-ranking, which is a very important capability. It's all part of a kind of a modern retrieval pipeline that makes sure that you get the best matching chunks before you send them over to the LM and say, hey, please respond to this answer, grounded in its very relevant information. So it's kind of garbage in, garbage out. If you don't get the right retrieval, you really are not going to get good quality results, which I'll talk about later on. And so the generative LM takes all this data, generates a response grounded in this data, and then the last step that we like to implement in our flow is hallucination detection, because a lot of times even that would still hallucinate, because the LM can still not show you the right results, even if it got really relevant context here. So I'll talk about this more later on. And generally at Vectara, kind of the baseline sort of what we do is, I think in 2024 and sometime in 2023, people built RAG pipelines on their own a lot. They still do to some extent. Everybody was picking their vector database, picking this, picking that. It turns out, as you can see here, it's quite it's not an easy system to build. You got to think about a lot of stuff. There's a lot more advanced techniques. So what we do is we put this around in a box. And so we manage all of the RAG stack. We manage all these components, all of these flows. We make sure everything is harmonized and works flawlessly together. And we expose an API, the indexing API and the query API, so that our customers really build RAG applications that don't have to become RAG infrastructure experts. This becomes much more complicated when you scale up, and things can go out of hand really quickly. And this same platform can be deployed, of course, on our systems, but also on any hyperscaler VPC, and on-premise even. So some of our customers have really strong demands for kind of airtight, sort of nothing leaves the premises. And so that's another interesting thing, because the same API, the same development, if you have 50 applications, you can develop everything with exactly the same API. And some of our customers have, 50, 100 different use cases, some of them on-prem, some of them on VPC. It's really nice to have this flexibility to, especially for teams, to move around and also develop under the same API. So that's generally RAG. I mentioned it deploys anywhere. I want to show you quickly a quick demo of probably the simplest version of that, and I'll make the font here a little bit bigger. But this is a form factor of what we call like a question answering, and so this is just the UI. And when I click on any of these questions or type in a question, it actually calls our query API. So, and I just wanted to show you what the API provides back. So it provides, of course, the response you can see here with citations. So you can get 1, 2, 3, 4, and you can look. I can actually click on these citations. I think it actually moves to the place, and you can click on where it came from. This, of course, is an example of news sources that we crawled, we indexed beforehand, because we can show you a demo of actual customer confidential data. So we use public data for the demo. But also you can see here, I talked about the hallucination detection. This is this is based on our hallucination score that came back with this response from our platform. So he calculated this response, and he tries to measure how much this response is hallucinated or not hallucinated given the sources, right? Like I described earlier. And so this is very helpful because it gives you this, in this case, we had these badges of high confidence, medium, and low confidence. But you can do, when you use this, you can do whatever you want. You can decide how to deal with this case. You can hide things that are very hallucinating, or you can just, do a lot of different things with that. So that's, again, kind of a really quick demo of that. And so kind of to summarize kind of the baseline, the really unique value of Vectara as a baseline is, as I said, standardized platform. We have this concept called a RAG sprawl. So if you ever worked at a bigger company and there's new things come up, there's a lot of teams that do them. So we see this coming up this year a lot, where companies have explored RAG and agents, and it's sort of like they end up having like 10 teams doing kind of the same thing for different applications. One is using this vector database, somebody's using the other vector database. People use OpenAI, Anthropic, this and the other. It becomes very quickly unmanageable for the IT systems to manage all these different systems. And so that's, again, a platform is very useful for that. As I said, we deploy anywhere, and we really focus on response quality. And I'm going to talk probably for the rest of this talk about response quality and about agents and how that plays together. Okay, so I talked about RAG sprawl. Let me skip that quickly, but that kind of demonstrates that. So I'm going to talk about hallucinations a little bit, and then agents, and then about response quality, okay? So I mentioned hallucination detection. This is an example, kind of about a year ago, when you asked ChatGPT, did Will Smith ever hit anyone? And the response was, no, he's a pretty decent dude, like no problem. And we all know what happened, which is this, right? In the Oscars of about 2 or 3 years ago. So he hit Chris Rock on stage. So we all know hallucinations. This is an example of a LM hallucination. You just ask it about something and it knows or doesn't know the answer. As I mentioned earlier in RAG, the hallucination is really like the facts that you bring into the LM to ground on. Did the LM still do a good job reflecting that? And even with RAG, which helps reduce hallucinations, there's still a pretty significant issue for adoption, especially with companies that want to make this more than a toy POC. And so we see a lot of issues with that. If you guys have been tracking, there's a famous example from a few days ago. Did anybody here heard about the Cursor AI hallucination problem? No? Yeah. So Cursor AI had an unfortunate incident where they had a customer service situation where somebody called in and got wrong instructions. And I don't know all the details, but it turns out it was an AI that they created, not a real person. They didn't disclose this. And so there's a lot of uproar from the user community about not disclosing that it was actually a bot and giving them the wrong instructions and doing wrong things just based on hallucination. So doing hallucination detection and correction is really key to success when you deploy RAG and agentic RAG. Um, and we work a lot on this space. This is our open source version of our hallucination detection model. We contributed to the community about a year and a half ago. It's very popular on Hugging Face. It's probably the best known, the most popular hallucination detection model on Hugging Face today. It's about, I think at this point, 3.6 million downloads. Uh, excuse me. And we also publish a hallucination leaderboard, which measures the likelihood of each LLM model to hallucinate, again, in the context of RAG. And you can see that a lot of the models are listed here. This is the top 25. And a lot of the models have actually improved a lot. So Gemini, for example, 2.0 here is leading the pack. Gemini 1.5 wasn't that good. It was like 4 or 5% hallucination rate in this context. So I think the LM providers are actually getting better at this. Now, I wanted to talk here about hallucinations before I go into agents, just to emphasize how important it is. And in agents, it's even more important than in the basic RAG, because imagine you have a 10-step agentic flow and you hallucinate in step 1, you can go off the rails really quickly and nothing else matters if you kind of go the wrong direction. So it's really important to do that. I want to show you one more thing that's really cool. This is the hallucination correction model. So I'll go to the demo here, but this is just demonstrates that it's a demo of a model that we have in tech preview right now. What it does is, you detect a hallucination. I showed you how you show the badge. That's fine. But what happens if you want to actually do something about it? So hallucination correction is actually that solution to that. So what it does is, so here we ingested into Vectara a HR benefits kind of PDF of about 100 pages or so. And when we send a query to Vectara about will benefits cover care for my parent, of course the answer is no. And there's a good answer here. So Vectara actually did a good job. It was hard for us to craft a query that it would hallucinate on in this case. So we changed the query response artificially to make it incorrect. So we created this query out of this one just for the sake of this demo. And as you can see, the hallucination score now is really low, meaning it is detected as hallucinated. That's great. Here it was 97%. And now I'm going to send this particular response, which I modified, into the hallucination correction model. And what that does is it takes this response and changes the minimal amount of words or characters in it to assuming that it's detected as hallucinated to make it correct. So that's a step you can take after you got the response from your RAG pipeline, and you want to potentially think about correcting it and showing the user to correct the one. And that flow and it's all these steps again makes the whole flow much better quality overall. Okay. So I talked about hallucination detection, hallucination correction. Now let me talk about agents. So I think there was a talk earlier today here just before me about agents. There's a lot of talk about agents. So I'm going to talk again about agents in the context of what we work with our customers, which is in the enterprise, and things that are kind of what we call agentic RAG. They use RAG as an underlying frame. So generally, when you talk about agentic, and Vectara Agentic is our framework for that. That's open source, and you can look it up later on. You think about an agent as an LLM brain that essentially has reasoning and planning capabilities to decide on its own, or with some guidance sometimes, how to answer a user question, given what we call tools that it's been given. So imagine a tool could be a call to Vectara RAG. There could be maybe a couple of those. A tool could also be, well, essentially it's any Python function you want. So it could also be a call to an API that's internal to your company. It could be a SQL query. It could be anything you want. So it's really flexible in that sense. And the nice thing is that the agent sort of gets a user query, kind of looks at it, the LM looks at it, decides what to do, which tools to call, in what order, calls the tools, get the responses, kind of collects all this information and creates a very nice response back to the user based on all the information that is collected. So I'm sure you've seen this a little bit if you've looked at agents. This is a very standard flow. And I wanted to show you a particular example of that. And I'm going to show the code a little bit too. And with Vectara Agentic, what we try to do is make it really easy to use. So a lot of these frameworks, you have to code a lot and kind of understand their particular infrastructure and how they work. And here we try to make it kind of not completely drag and drop, but more like very easy to use and not a lot of coding. So here's an example of a electric vehicle assistant kind of agent. So what you see here is I'm creating two tools. One is called the EV information tool, and one is an EV loss tool. These are two data sets. One that includes information about electronic vehicles, and one that has about regulations. We ingested them into Vectara, and you can see we do this create RAG tool, which is one line of code. Give it all the configuration of how to query Vectara in the API, and it does all the legwork behind the scenes to create that. And then here in this case, I also created a set of database tools. So the third thing that we have here in this particular demo is a data set, a database. It came as CSV files. We'll put it in a database that has electric vehicle information in the state of Washington, just for fun. So I put it in there to show that actually it could be really helpful to answer kind of more analytical question like that we'll see. And so this is a set of tools, which we'll see in a minute, that can query a database. And in this case, we had four tables in there that we plugged in. And essentially to generate the agent, you give it some instructions, like these, for example. You give it the tools that you have, and the instructions, a topic, and that's it. And the agent's ready to go. And you can start asking it questions. So I'm showing you a little bit of this code just to show how quick and easy you can work with it, and connect it to Vectara, connect it to other tools, etc. So let's look at what this looks like here. I'm gonna again make this a little bigger here. Can you see this okay? Yeah. All right. So this is the demo. It's kind of hosted on Hugging Face here. So I want to show you, for example, this query. So I'm running this query again. And what I'm going to do is when this happens, it just calls agent.chat in the background and shows us the result. So if I click on this, you can see that this example is a mix of a sort of a text part of the question and kind of an analytical part, right? And the agent is really, because it's based on the LLM, it can actually understand that this is a compound question and call different tools to figure out different parts of the answer, right? So you can see that it created this part of the answer here. Okay, this is probably going to the RAG tools and giving the answer, and it's got the citations here as well, but also gave us a really good answer on the analytical question. So how did it do that? Let's look inside a little bit. So here's the logs of kind of what happened underneath the covers. First, the agent the first step was it got this question, and it called this Ask Vehicles RAG tool, and you see it actually kind of picked up the right part of the question that's not analytical from the overall compound question. And this is running, by the way, in parallel, so it's not question, answer. It's going to be a little bit mixed, but the answer you can see is kind of here from this tool. It gave us a long answer, a little bit cut off with a ... to save on space. But that's how we got the answer to that part. And then there was this analytical part of the question. So here it used the tool. So it first decided to call this tool called list tables, which said, tell me all the tables that it has. Now, again, the agent doesn't know which tables it has. It just has access to the tools. It doesn't know which tables exist. So it knows now that these are the 4 tables. Then it called describe tables for this particular table because it kind of figured out that it's about registration. So that's the one that matched. So it called, and it kind of wanted to know the schema. So here it says, okay, this is the schema. You got columns and their types, etc. Um, and then the next thing it did is actually just create this query completely on its own and call this EV data to get exactly the information that it needed. And then it kind of took all this information together and created this answer for us. All right? So that's really how this agentic works. So super easy to set up, meant to be kind of a higher level, and works out of the box with Vectara. All right. A couple things when you design and work with agents, just to finish up that piece. Well, you use an LLM to drive this whole process. Not all LLMs do as well in tool use. So part of the thing that the LLM does is it chooses the right tool to call in the order. So I have a thing here about the leaderboard. There's a leaderboard about tool use. And not all LLMs are the same, so pick ones that are good at that if you use that. Pay attention to your tool definition and carefully use the instructions. Some people tend to put too much instructions and overfit on the instructions. So just try to do minimalistic things if you give it specific instructions. Let the LLM do its thing. A lot of times we think that our instructions are very clear, but the LLM actually doesn't understand it, and when you look carefully, you kind of sometimes understand why. So this is a couple of tips that we've learned over the years how to do this. And before I end, I want to give you one more exciting thing to share. We just announced this 2 weeks ago, a new open source package for RAG evaluation. RAG evaluation is really, really important, both in RAG and in agentic RAG. And one of the problems is it's not been really successful so far. And one of the reasons it's not been successful is because it was hard to implement. So we launched this thing to solve this problem in 3 ways. One is it is an open source, very transparent open source project. We did this in collaboration with the University of Waterloo and research there, and I'll have some more about this in an instant. And the most important thing is that when you do RAG evaluation, you usually have to define the queries, and you have to define the kind of the golden answers or the golden chunks that you want in the middle. And defining those is really hard. I mean, you have to, if you want to do a lot of questions, you have to sit down, and sometimes it's not even clear what the right answer is. If you have a person doing this, and a human being, they may not know what the right answer is or what the best answer is. So this idea of having no golden answer required is really key to scale this up. So I want to talk just for 2 or 3 minutes about this. And I encourage you to look at this later on, and you can ask me questions afterwards. It uses these very unique metrics, again, that we developed with collaboration with University of Waterloo, a great team there, run by Jimmy Lin, Professor Jimmy Lin. So one is umbrella. It's a retrieval metric that actually doesn't require you to know the right answers. It uses this scoring mechanism of 0 to 3 to score potential chunks against the query, how relevant they are. And the nice thing about this is that it correlates with human judgment. So it's not just some method they came up with. It's a method that they've proven and shown a lot of research on a lot of data sets really correlates with human judgment. So that's really good. There's something called auto-nuggetizer that measures the generation quality. There is a measurement for citation faithfulness, how much the citations really represent and are correctly representing a good answer to this question. And of course, hallucination detection, which I talked about earlier, and it uses our HHEM model for that. So I encourage you very much to take a look at that. This is a little bit of a chart. I mean, RAG evaluation is not, it's not a new thing. It's been existing for a while. Here's some of the other sort of things that we're aware of, the people who do that. But again, the point is that this is very open source, very transparent. We have building collaboration with a lot of other companies to contribute that and make it a really truly community-driven project. And then it's also very easy to use and uses these great metrics that allow it to be no golden answers required. And so I wanted to share this just to encourage everybody to share this around. If you're interested to contribute, we're very open to that. You contribute additional metrics to it, additional evaluators. It's a connector plugin based thing. So if you have your popular RAG framework that's not Vectara, that's unfortunate. I'm sorry, no, I'm kidding. But you can definitely contribute a connector to that framework because it's meant to be compatible with anything out there. And we'd love to hear from you about that. And this QR code you can, and if you're out there, also spread the word around, give us some good stars on GitHub. They'll be always appreciated. That's all about me. If you want to try Vectara, either our RAG service or our Agentic framework, here's some resources for you. We have a Discord server. You can contact us to get more information.